This is the most challenging video I've ever made. I've set myself the task of recreating scenes from my favourite DOS game, Super Zaxxon, in OpenGL. And for that, I'm going to need 3D objects which I'm creating with Blender on my Windows XP machine. But every time I try to export to the Wavefront 3D object format, it dumps me to the desktop. Now this is Blender 2.49, let's see if it's any different. And it's worked! It creates this really simple object format which is actually just human readable. Each of the points in the object is given by a triple of values, x, y and z coordinates. And then at the bottom you've got all the faces on the objects which are just indices into that list of points. So this is really easy to import into OpenGL. Of course when I said easy I really meant hard. I've written a program to make a window and move it to a particular spot, and then it's going to open the object file we created with the cylinder object in it and break it up into vertices, triangles and quadrilaterals. So it just reads all that data into memory and then does some basic OpenGL setup stuff. Here's the function for reading in the file, and at the top here is the next function that it runs, which just draws a little red rectangle on the screen just to make sure OpenGL is working. So let's run it and see what happens. And you can see it says that it read in all the vertices, triangles and quadrilaterals from the file, and there's the red rectangle. Well, I've written all of the code to display the object, and look at this, it's so realistic, and it rotates, it's got textures. Yeah, alright, okay, so it's hard. I need to read the damn book, and I haven't done this for 15 years, alright? This didn't turn out to be too difficult after all. The way OpenGL works is you provide it with a function that it's going to call every time it needs to redraw the display. And so I just provided it with a function called display here. And basically you can set a color, clear the screen, tell it where the camera's pointing, how big everything's going to be and so on. And this one here selects the wireframe mode, this GL line, and then I specify where all my vertices are. Now I've got those in an array in memory called vertices, and then we just need to get it to loop over all the triangles and all the quadrilaterals and draw them. And so those are in the triangles and quads arrays. They are just indexing into the vertices, and that's all there really is to it. So now when we run this, it displays the cylinder. Isn't that amazing? Well, it took me quite some time, but I've managed to get the lighting working, and this is the most difficult part so far. There's a whole load of lighting options, not just for the lights, but also for the objects they're shining on. Now, the simplest possible way you can do things is flat shading, and this just means that any given polygon in the object has all the pixels the same color. And you can make it even simpler still by having no lights in the scene, so that it doesn't really matter which direction the polygon faces, it's going to be the same color. But this looks very unappealing. As you can see, it's still a cylinder, but just has no three-dimensional appearance at all. But flat shading doesn't need to look so bad. If we turn lights on, then we end up with a much more appealing look. So this time, the polygons have a different shade depending on whether they're facing toward or away from the light, and it already starts to get a kind of three-dimensional appearance. But of course, if you want to make things look really realistic, you have to enable the full force of OpenGL's lighting and turn on smooth shading instead of flat shading. And now things will look a whole load more realistic. So as you can see, there's all sorts of lighting effects here. There's an ambient lighting. You can see that the colors change fairly smoothly. And also there's a kind of specular highlight. There's some kind of white light above the object. There's not that much code to write, but it takes a while to figure out what to write and what it all means. The object parameters are here, including the specular component of the reflection. This is the white shiny bit that we saw on the cylinder. There's also an overall shininess of the object, and you can also specify separately ambient and diffuse components of the light. For real-world objects, they're almost always the same, and usually the color of the object, so I just made that red. And I reflect just a small proportion of other wavelengths because all real-world objects do that to some extent. Then there's the light. There's only one of those in this scene, and I select a position for it, and it's a white light, which is a standard thing to do. And then I have an ambient light. This is not a ray tracer, so it's not tracing rays around, and in the real world, light bounces off all sorts of things and kind of mixes up, and you get this ambient light which doesn't seem to come from any specific direction but just brightens everything in the scene, and so that's what this is for. Now, the other thing that you need for lighting is normals. These are vectors that point out at 90 degrees from each of the polygons in the object. And I discovered later that OpenGL actually has an option to compute those for you, although it is slower if you do that. So I have code here for computing normals for all the triangles and all of the quadrilaterals and putting those values into arrays. And then it's basically just a matter of setting those material properties, the specular and shininess values and ambient and diffuse components of the reflection for the object. And down in the init routine, I also set up the lights themselves. Obviously, I need to turn on OpenGL lighting. There's just one light in the scene. It's called GL Light 0. And I set its properties, its position, its white. And I also choose a lighting model. In this case, it's the ambient lighting model. That's basically all there is to it. You also need a depth buffer so that it can tell which objects are in front of other objects. And away you go. As usual, time is running down for me to make this video, and I still haven't made all the objects to go in the scene yet. Now, my copy of Super Zaxxon got corrupted, so I'm showing you Zaxxon here, and unfortunately it runs so fast on this machine, it's just over in a split second. So I've just paused on the game over screen so we can see some of the objects. There's obviously a turret, there's a rocket ship, I believe there's a kind of cylindrical object and another one that looks like a radio antenna. Anyway, that's what I'm going for. I probably won't get all of those done. And I'll also need a brick wall, and for that I can just use a cube and squash it down so it's flat in OpenGL. So time for me to give myself a crash course in how to use Blender. I've constructed a couple of objects in Blender and the results are mixed. The best one is probably this turret, which looks quite good now. But this might be because I made some changes to the code. It seems that OpenGL does much better if you give it a normal per vertex of a polygon instead of just a single normal for the whole polygon. Once I made that change, the lighting looks a whole heap better. The other thing I discovered is it probably can't compute the normals for you. You have to do that yourself, but it can normalize them, in other words make them length 1. So I've enabled that option. The other object I've done is a rocket, and my Blender skills are holding me back a bit here. You can see it doesn't quite match up in places, and for some reason the lighting just doesn't pop as much as it does on the turret. Okay, here it is folks. You can see I now have some objects scattered about on a kind of platform, and there's a brick wall. So the wall pieces and the platform are just squashed cubes. And it was actually relatively easy to do this. So OpenGL offers some primitives for translating an object, so moving it in any direction, for scaling the object, so you can make it any size you want, and also even rotation, so I was able to rotate the turrets. Of course, I had to write some code to read all of the different object files in and store them in separate objects in memory, but that wasn't too hard to do. And the only thing that really remains now is some texturing on the objects and maybe even some animation. Let's see how far we get. It turns out that texturing is quite a complex issue. I'd have to write code, for example, to load images from disk. And there are some great libraries out there for textures. There's one associated with the Blender program which has a huge number of textures in PNG format. But instead of doing that today, what I'm going to finish off with is some animation. And this turns out to not be too hard. We just need to have a frame counter that gets incremented every time the display function's called. And we use that to change the position that we're looking at the image from using this GLU lookat function. Now there's only one other trick that I needed, and it was quite difficult to find because it's not mentioned in the book that I've got. When you finish the display function, you have to call glut post redisplay, otherwise it just displays the one frame and stops right there. And once I'd figured that out and also enabled double buffering so it doesn't flicker, it seems to work and looks exactly like the Zaxxon game. Let me know in the comments what you think. And if you want to try out some OpenGL programming for yourself, take a look into the tutorials by a guy called Nehe, N-E-H-E. This is what I used back in the day to learn OpenGL programming, and they're really great. Anyway, that's all I have time for this week. I hope you've enjoyed this look at OpenGL, and we'll see you in a later video. Bye.